All right, welcome. Today we're going to tackle a really interesting puzzle. Artificial intelligence is everywhere. It's incredibly powerful, but why does it feel like it's kind of hit a wall?
I mean, think about it. AI is moving at this insane speed, right? It's writing code, translating languages on the fly, creating art that, honestly, it feels like it's straight out of a sci-fi movie. But even the people building these things, the real experts, have this nagging feeling that something really important is still missing.
Now, one of the key figures who's been talking about this is Yann LeCun. I mean, this guy's a giant in deep learning. And his whole point is that just making things bigger, throwing more data and bigger models at the problem, that's just not going to cut it. He says a truly intelligent system needs something he calls a world model. And that idea, that's going to be our roadmap for this whole discussion.
So to really get a handle on what this limit is, we have to define it a bit better. So let's start with section 1, just getting a feel for this wall.
Now, this wall we're talking about, it's not about AI failing. It's actually the opposite. It's succeeding like crazy. The problem is more like, imagine you're in a race car that's going 1,000 miles an hour. You have direction, for sure, but you have no map, no orientation. We're accelerating, but are we even on the right road? The road to what you might call real general intelligence? We're not so sure.
Okay, so if it's not a performance issue, then what is the problem? What's the missing piece of the puzzle? That brings us to section 2, where we're going to dig into the real bottleneck here.
So the whole thing really boils down to this. We've been confusing two totally different things. On one hand, you have performing a task, writing an email, solving a math problem. Current AI is an absolute superstar at that. But then there's the other side, recognizing what kind of problem you're even looking at to begin with. And that's the real hang-up.
And the fallout from missing this distinction is massive. It means you can have an AI that perfectly solves one tiny specific problem, but it has zero global coordination. It can spit out the right answer without any clue about the bigger picture, the context, the risks, the ultimate goal. It's kind of like having a room full of geniuses, but they can't talk to each other to figure out what they're supposed to be building.
So here's the big takeaway so far. We have to completely rethink what we mean by general intelligence. It's not just a checklist of skills, right? Can it do language? Check. Vision? Check. Reasoning? Check. No. It's the coordination capacity. It's the ability to look at a situation, figure out what kind of problem it is, and then switch gears to the right strategy.
And if we want to understand that kind of coordination, well, there's really only one place to look. The one system that has absolutely nailed it, life. Which brings us to section 3, Evolution's 5 tasks. Think about it. Every single living thing on this planet, I don't care if it's a tiny amoeba or a giant elephant, is playing by the same 3 rules. These are the non-negotiables. You have to manage your energy, you have to stay safe, and you have to reproduce. That's it. Any real general intelligence has to be built on top of solving these basic primal problems.
So to deal with those big 3 constraints, life came up with this sort of scaffold, a set of 5 core tasks. It started super simple, just controlling the stuff right around you. Then, okay, now you have to deal with other things that are moving around, predators, food, potential mates. After that, a massive leap forward, learning to control perception and signals. Think camouflage or a bird's song. Then came an even trickier one, figuring out how to navigate complex groups. And finally, the big one for humans, controlling symbolic stuff, like language. And what's so critical here is that each new layer was built right on top of the last one. Nothing was thrown away.
Okay, so if that's evolution's framework, like the official report card for what makes something intelligent, how does our current AI stack up? Let's give it a grade. Section 4, AI's missing pieces. And this is where it gets really interesting. When you actually map AI against this list, the picture is, well, it's weird. Task 1, controlling the environment. That's your thermostat. We solved that decades ago. Task 2, dealing with moving things. Yeah, we've got that with self-driving cars and robotics. And then, crazily enough, AI just leaps all the way to task 5, symbolic systems. That's exactly what a large language model is. But wait a minute, look what it skipped. Task 3, shaping perception, and task 4, group dynamics. It's like AI just completely skipped over the messy, complicated social stuff in the middle.
So the real diagnosis here isn't that AI isn't capable. It can do mind-blowing things. The problem is that its brain is in pieces. It's a case of fragmented cognition. Its intelligence is all broken up into these separate, uncoordinated parts. It can write you a flawless poem, but have absolutely zero clue about the social context it's operating in.
And, it's probably not a coincidence which pieces are missing.
They're the uncomfortable tasks, the messy ones. Shaping perception, that's about influence, persuasion, even deception. And group dynamics, that's not just holding hands and collaborating. That's about competition, power, rivalry. It's literally all the stuff that we get a little nervous about when we think of a super powerful AI.
But here's the twist, and it's a really important one. This isn't a moral argument. Nobody's saying let's go build a deceptive, power-hungry AI. It's an architectural argument. The point is that these uncomfortable tasks are a fundamental part of the world that intelligence evolved to deal with. You can't just pretend they don't exist, leave them out of the blueprint, and still hope to build a complete, truly intelligent system.
So, okay, if that's the diagnosis, what's the cure? How do we move forward? Well, that takes us to our final section, and a possible path out of this mess. Section 5, the path forward, is assembly.
And this right here, this is the core idea. The way we're doing AI right now is all about scaling. More data, more power, just make everything bigger. But that's not what biology did, at all. Evolution didn't just scale up one big brain, it layered it. It added new systems on top of the old ones. It assembled intelligence, piece by piece, like Legos.
You know, this idea isn't even new. It takes us way back to the early days of computer science, to this field called cybernetics. A guy named Norbert Wiener called it the science of steering. And it's a great analogy. Think about a ship's captain. Their job isn't just to slam the throttle to max speed. No way. They're constantly adjusting to all these constraints. The wind, the ocean currents, how tired the crew is, all to keep the ship safe and on course. That is what real intelligence looks like in action.
And this brings us full circle, right back to Yann LeCun's world model. See, a world model isn't just a big encyclopedia filled with facts. It's an active, living control system. It's the captain on the bridge. It's the thing that looks at a situation and says, okay, is this a simple chase the ball problem, or is this a complex social negotiation? And then it switches to the right playbook. It regulates its own behavior.
So we're left with a pretty provocative question, maybe even a little unsettling. If the only general intelligence we know, our own, evolved to handle a world that's not just about rules and resources, but it's also filled with rivalry, deception, and social games, then to build an AI that's truly general, do we have to build in the capacity for those uncomfortable, messy, and maybe most deeply human parts first?